Okay, we're going to do a little bit of review of trig that you would have done last year in geometry. We're also going to add a couple of new trig functions to this as well. Just to remind you that when you were doing sine, cosine, and tangent, they were all three on your calculator, but the abbreviation would have been sin, cos, and tan. And to evaluate those or to get decimals out of there, you're always going to put an angle in there with them. Make sure your calculator is in the right mode, and I can help you out with that a little bit later. Now, the three reciprocal properties, though, would be cosecant, which is 1 over the sine of A. It's got an abbreviation of CSC of your angle A. Secant, which is 1 over the cosine of angle A, or SEC of A, or secant. Cotangent, 1 over the tangent of A, or COT of A. Now, I say that, hey, we got tangent and cotangent make sense that they go together because they both have the word tangent in it. The way I remember that cosecant and sine go together is S and C are mixed up, and C and S are mixed up. Okay, that might help now, maybe it'll help a little bit later. Anyways, theta, sometimes you might see me put a little O with the slash through it. Typically in geometry, you would have named the angles with 3 vertices, A, B, and C, and the side lengths would have those letters as well. We'll still use that, but if you see theta, it just means that we're talking about an angle measurement. Oh, sorry about that. So the sine of theta is a fraction. So there's my theta. We have the opposite side of angle theta, so opposite over the hypotenuse. We have the adjacent side for cosine, so adjacent over hypotenuse. And the tangent of opposite side over adjacent. Now the reciprocal properties are just those flipped upside down. So the hypotenuse over opposite, we've got hypotenuse over adjacent, and we've got cotangent of adjacent over opposite. A way to remember these might be the phrase so, ka, toa. And the reason why I write them like that is because sine is the opposite over hypotenuse fraction. So cosine is the adjacent over hypotenuse fraction. And tangent is the opposite over adjacent fraction. So, ka, toa. All right, so to come up with the 6 trig functions is just talking about trying to find the 6 ratios or fractions that go along with that. I changed theta, it's up here, so now this is my opposite side. 5 would be my adjacent side, and hypotenuse is going to be the one that's always opposite of that 90-degree angle. So for my sine, it's going to be opposite over adjacent. Oh, I'm sorry, hypotenuse. Adjacent over hypotenuse. And for tangent, the opposite over adjacent. Now, my reciprocal of cosecant would be 13 over 12. I just flipped the fraction. 13 over 5. And 5 over 12. Okay, the 3 reciprocals. Now, what to do if I don't have the missing side? Well, in a right triangle, I can use the Pythagorean theorem, where these two would be the legs, and this is supposed to be an equal sign, is supposed to be the hypotenuse. Now, I'm trying to find the hypotenuse, and here are my legs. Now, A and B are interchangeable, so I'm going to take 5 squared plus 10 squared and set that equal to c squared. So 25 plus 100, go through, and I'm going to take the square root. So that ends up being 5 square roots of 5 in simple quadratical form. So the sine of theta, here's my opposite, here's my adjacent, will be 10 over 5 square roots of 5. Or with a little bit of simplifying, 2 square roots of 5 over 5. So the reciprocal of that is going to be the square root of 5 over 2. Now the 10 and the 5 reduced, and that's how I got the 2. Cosecant. So it's going to be 5 over 5 square root of 5. Okay, so the square root of 5 over 5. Or if I take the reciprocal, that's the square root of 5 over 1. Tangent. Okay, so opposite over adjacent, 10 over 5, which turns into 2. Or the reciprocal of that, which would be 1/2. Now, how the Pythagorean theorem is going to help me out and the angles are going to help me out is to solve a right triangle. And what that means is to find all the missing lengths and all the missing angle measurements. Well, to find the missing sides, I'm going to just go through and label that the C is going to be my hypotenuse. 6 is my adjacent. B is my opposite. Opposite of what? The angle that was given. So I'm going to go through and let's say just for the sake of alphabetical order, I'll put B. I'm going to use SOHCAHTOA, and opposite and adjacent is tangent. So I'll take the tangent of 62 degrees equals the opposite side over 6. Now the tangent of 62 is a decimal that you can get using your calculator, and don't worry, you'll be using calculator for these types of problems. That works out to be 1.88. If you didn't get that with your calculator, we need to make sure we check out some settings. I'm going to multiply both sides by 6, and that tells me that B is about 11.28. Now, if I want to use the adjacent and now the hypotenuse, now I'm going to use the cosine. So I'll go the cosine of 62 degrees is equal to the adjacent 6 over the hypotenuse of C. Now, this with a little bit of algebra, I'm going to divide by C, or I am dividing by C, so I'll multiply by C to get that by itself. To get C by itself, I'll divide by the cosine of 62.
Nehemiah Halverson, Amber Wybe, Pasha Rashid.
So C ends up being 6 divided by the cosine of 62.
Isopi Nunyi, Aaron Nowaski.
So about 12.7. So now I've got A, B, and C as my distances. I can figure out that angle because remember, all three angles add up to 180 in a right triangle, or any triangle for that fact. So 63 or 62 taken away from 180 minus 90 leaves me with 28 degrees. I know all three angles, I know all three sides, so there I've solved my right triangle.